In this lesson, we are going to learn how to simplify rational expressions. We're going to work in section 9.1 in your textbook on pages 698 and 699. And we're going to work problem numbers 2 through 36 even. So, rational expressions. Rational expressions are just a fancy way of saying fractions. So, on numbers 2 through 8, they state, evaluate each expression for the value of the variable. So for number 2, we have 4x divided by 5x minus 6, and we're evaluating that for x equals 2. So when they say evaluate each expression for the value of the variable, all they're asking you to do is plug in this 2 in place of the x's over here. So when we plug in a number for a variable, as we learned in the last lesson, we always plug that number in with parentheses surrounding it. Just like this. So every time we see an x, we're going to use the parentheses and we're going to put the number 2 inside. So to solve, you work your numerator, work your denominator, get them both as simplified as possible, and then you divide. So 4 times 2 is 8. 5 times 2 is 10. Then bring over your minus 6. Then simplify by saying 10 minus 6 is 4. And then 8 divided by 4 is 2. Ensure that you do not put 2 over 1. That's not all the way simplified. Simplified is going to simply say the number 2. Okay, moving on to problem number 4. We have 4x minus 7 divided by 2x minus 1, and we're going to evaluate that for x equals negative 2. So every time I see an x, I'm going to plug in negative 2. Okay, so now I'm going to simplify. When I'm simplifying, take care of your multiplication first, then your subtraction. So 4 times negative 2 is negative 8. 2 times negative 2 is negative 4. And now you combine your numerator and denominator. So negative 8 minus 7 is negative 15. Negative 4 minus 1 is negative 5. And then negative 15 divided by negative 5 is going to give you a positive 3. Looking at problem number 6, we have 4x minus 5 divided by 2x squared minus x plus 3, and we're going to evaluate that for x equals negative 1. So everywhere I see an x, I'm going to plug in that negative 1. So 4 times negative 1 is negative 4. We're going to bring over that negative 5. And then down here, remember your order of operations are parentheses, exponents, multiplication, division, addition, and subtraction. You have got to take care of these exponents first before you can multiply the 2 times the negative 1. So negative 1 squared means negative 1 times negative 1, which is positive 1. This is saying the opposite of negative 1 is 1. And bring your 3 over. So negative 4 minus 5 is negative 9. 2 times 1 is 2. And I can go ahead and add that 1 and 3 to give us a 4. 2 plus 4 is 6. And then to simplify, we divide by a 3 on that numerator and denominator. So that's going to give me a negative 3 over 2. Moving on to problem number 8. We have 3x plus 1 divided by x squared minus 5x plus 6. So I'm going to plug that 3 in place of all of my x's. So for my numerator, 3 times 3 is 9. Bring over your 1. And then you got to do your exponents here. So 3 squared is 9. Negative 5 times 3 is negative 15. Bring over your 6. 9 plus 1 is 10. 9 minus 15 is negative 6. Bring over that plus 6, which gives you 10 over 0. Some of you might be tempted to put the answer 10. Some of you might be tempted to put the answer of 0. That is not correct. The answer is undefined. You can never have 0 in your denominator. You can never divide a number by 0. So when we have that, we call it undefined. And that problem is actually going to lead us into the next section. They're asking us for what value of the variable is each rational expression undefined. So here we've got problem number 10. Y divided by y plus 7. They say for what value of the variable, meaning what number can I plug into that y, will each rational expression, so will each fraction, be undefined. Remember, undefined means 0 in the denominator. Okay, so what can I plug in down here to make that a 0? So what I can do is I can set this equal to 0 and then solve for y. I know a lot of y'all are going to say, it's negative 7. That's easy. They get a little harder as you go along. Okay, so you subtract 7 from both sides. Your answer here is going to be negative 7. So for what value can we get a 0 down here? What can I plug in? Negative 7. Okay. The numerator can be smiley faces and rainbows. It really doesn't matter what the numerator is. The only thing we're going to be considered about is the denominator. Okay, so now let's look at number 12. We have x minus 6 divided by 4. So they're asking, what can I plug in to this expression that's going to give us a 0 for our denominator? Whenever you have a number by itself, it's called a constant. That means that there is no variable next to it. It's constant. That means that it's never changing. So since this is never changing, that means that this can never be undefined. Okay, so on number 12, it would be never undefined, and that is a V, because there is no variable in the denominator. So if there is no variable, then it can't ever be changed. Looking on number 14, we have 4x minus 5 divided by 5x plus 2. So we just learned in problem number 10 that all we have to do is set that equal to 0 and solve for x. And remember, we're only concerned with the denominator because the denominator is being 0 is what makes it undefined. So I subtract 2 from both sides. So you get 5x equals negative 2. Divide both sides by 5 to get x equals negative 2 over 5. So that's what you can plug in to that variable to give you a 0 for the denominator. So negative 2 over 5 is your answer. Problem number 16, 3x minus 7 divided by x. Set your denominator equal to 0 and solve. Well, in this problem, there's nothing we can solve here because the x is already by itself. So that means that the number we can plug in is going to be 0. Okay, so now let's look at problem number 18. So on number 18, we have x plus 2 divided by 3x minus 7. So set that 3x minus 7 equal to 0 and solve. So we add 7 to both sides, divide by 3 to get x equals 7 over 3. Okay. Now let's look at problem number 20. We have 2x plus 7 divided by 3x plus 1/3. This one's a little bit more complicated. I probably wouldn't give you a question like this on a test unless it was a bonus. So don't stress about this one too much. But we would subtract 1/3 from both sides to get 3x equals negative 1 over 3. Then we would divide both sides by 3, giving you x equals. So if I have negative 1/3, if I'm dividing it, remember it's keep, change, flip. Change that to multiplication. Instead of 3 over 1, I would have 1 over 3. So to multiply those, you would multiply straight across to get negative 1 over 9. Again, don't stress out about that one. That would be more of a bonus problem. Alrighty, so now let's look at the next part of our lesson where we're actually simplifying these rational expressions, so simplifying fractions. So on number 22, we have 45 divided by 75. That's very easy. You should have been able to do that in order to get into this class. So what we would do here is find a common number. 5 is the easiest one to see. So I would divide both of them by 5. That would give me 9 over, sorry. So 9 over 15. Okay? Now I can simplify it even further by dividing them both by 3, which gives me 3 over 5. So all we're doing is simplifying fractions here. Problem number 24. I have 30x to the 8th divided by 25x to the 3rd. So if I've got 30 divided by 25, well, the common number between those is 5. So that would give me a 6 in my numerator and a 5 in my denominator. 30 divided by 5 is 6. 25 divided by 5 is 5. And then x to the 8th divided by x to the 3rd. If you remember from Math 94, when you divide your bases, you subtract those exponents. So 8 minus 3 is 5. And our x to the 5th would go in the numerator because 8 was larger than 3. Now it is completely simplified. We are finished. Problem number 26. We have 18a squared b to the 3rd divided by 24a to the 4th b to the 3rd. So my common number that I can divide by here is 6. 18 divided by 6 is 3. 24 divided by 6 is 4. Then I've got a squared divided by a to the 4th. When you divide your bases, you subtract your exponents. So 4 minus 2 is 2. And my a squared is going to go in the bottom because 4 was my larger number. And since 4 was on the bottom, my 2 goes on the bottom. If that's confusing you, you can always draw a picture. So I've got an a squared up here, a to the 4th up here. These a's cancel, leaving you with those two a's, and they're on the bottom. So if drawing a picture helps you, then that's fine. And then b to the 3rd divided by b to the 3rd. Remember, when you divide something by its exact self, then it cancels out. So your answer here is 3 divided by 4a squared. Okay. 28, negative 15 x cubed y cubed divided by negative 20 x y squared. Well, first off, a negative divided by a negative is a positive. Okay, so that's all we need there. So then, since our answer is positive, we don't have to worry about any negatives. 15 divided by 20, you can divide those by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. And what I'm going to do is, since that x doesn't have a written exponent there, I'm going to put that understood 1 just so you can see what it is. So we're dividing our bases, so we subtract our exponents. So 3 minus 1 is 2, and that x squared goes up top because 3 was bigger than 1, and 3 was on top. Then y to the third divided by y squared, so that leaves you with a y to the first. You can write the 1, or you can leave it off, it doesn't matter, but it has to go up top because that was where your larger number was. Okay. Problem number 30, we have negative 52 p to the fifth q to the third r squared, 39 p to the third q to the fifth r squared. Okay. First off, a negative number divided by a positive number is a negative. Right off the bat, we can go ahead and put that sign in our answer space so we have that finished. Now 52 and 39, this one is a little more difficult to figure out what your common numbers are. So you can actually divide both of those by 13. Okay, 13 is your common number here. So when you divide 52 by 13, you get 4. 39 divided by 13 is 3. So I got those two numbers by dividing each of these by 13. Now p to the fifth divided by p to the third is p squared. Q to the third divided by q to the fifth is q squared. So to the p squared went on top because the 5 was larger than the 3. And the q went on bottom because that 5 was larger than that 3. So you got to pay attention to where your larger exponent is. And then those r squares cancel. We discussed that whenever you divide the same exact variable and exponent with the same exact one, then they're going to cancel. Number 32. This one's a little bit different. We have x squared minus 25 divided by 3x minus 15. So on this problem, we're actually going to have to factor in order to simplify. So whenever you notice that you have more than one term, or when you see addition and subtraction signs, that's going to let you know that you're going to need to factor. So over here on number 32, x squared minus 25, this is called your difference of squares. If you are not really remembering how to factor the difference of squares, you can get a tutorial on my YouTube channel. It would have the difference of squares actually in the title. So I would factor that to be x plus 5, x minus 5, and then 3x minus 15. I would take out the greatest common factor of 3. And again, there's also a video on my YouTube channel of this, which gives you x minus 5 in the parentheses. So remember what we talked about with those r squareds. We talked about when we divide something by its exact self, it cancels out. So since I have x to minus 5s on my numerator and denominator, they're both going to cancel out. And I'm going to be left with x plus 5 divided by 3. Okay, so on number 34, I have 5y squared minus 10y divided by y squared plus y minus 6. So I would take my greatest common factor out of 5y in my numerator to get y minus 2. And then my denominator I'm going to fact by using the AC method. This video should be at the very top of your class. You should be able to see that video at the very top of all the links that I give you. It's also on my YouTube channel. I'm not going to do a review during this lesson, but I use the AC method for this. So this is called factoring trinomials. So that would give you y plus 3, y minus 2. So remember, we cancel out what we have that's exactly the same. And the reason we can cancel these out is because they're being multiplied. So I'm multiplying y minus 2 times 5y. I'm multiplying y minus 2 times y plus 3. You could not cancel these if there was a plus sign right here. Okay? So I'm left with 5y divided by y plus 3. Okay? So now moving on to the last problem of this lesson, which is problem number 36. On number 36, we have 2m squared plus 11m minus 21 divided by 4m squared minus 9. So my denominator I can factor by using the difference of squares method, which I call the car. It's exactly what we just did on number 32. So it's what we just did here. Okay. So I'm going to go ahead and do factor that denominator first, just because it's a little bit easier in my mind. So I'm going to get 2m plus 3, 2m minus 3. Okay, so to factor my numerator, I've got 2m squared plus 11m minus 21. I'm going to use my AC method. And if you watch my video on the AC method, I explain all of these steps and we do plenty of examples. So I need to find out what multiplies to give you that negative 42 and adds to give you that 11. Okay, so I'm going to write out my factors of negative 42. So I need one positive and one negative. So I'm going to make this be my pair, because negative 3 times 14 gives me negative 42. And then negative 3 plus 14 gives me 11. So before I write this out, I have to simplify. So I get 2m minus 3 and m plus 7. So my 2m minus 3's are going to cancel, leaving me with an answer of m plus 7 divided by 2m plus 3. Alright, so I hope that this lesson has helped you and I wish you the best of luck.